So, welcome to chapter 2, acid, bases, and salt. So, before going into the chapter, all of you go to page number 18 and activity, what was it? 2.1. Here, list of some acids and some bases are given, which are very much necessary. So, let us check those. So, the bases given here, acids given here are HCl, H2SO4, HNO3, and CH3COOH. And if you go on the other side, your bases are given as NaOH, then we have got KOH, then you have got CaOH2, MgOH2, and the last was NH4OH. The names are already given. Here our HCl stands for hydrochloric acid, H2SO4 stands for sulfuric acid, HNO3 stands for nitric acid, and CH3COOH stands for acetic acid. Here our NaOH, OH means hydroxide, Na means sodium, so sodium hydroxide. Here, so potassium hydroxide, calcium hydroxide, magnesium hydroxide, and this is NH4 is ammonium, so ammonium hydroxide. So these are our acids and these are our bases. Before going into details about acid and base, let's try to see what are the common things we can see in all of the acids this side and all of the bases this side. What is the common thing we see? For the base, the common thing we see is the presence of OH in all of them. You can see here OH, 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 and OH. That means what is OH? Hydroxide. So the common thing in all acids will be, all base will be, they will have a hydroxide OH. What about the acids? The common thing, all of them will have H, 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 and here the H is on the right side. Acids, all of them will have H. Keep in note, this side on the base it is OH. On the acid side this is not OH, this is double OH, and double OH is similar to having just a single H. Okay, double OH and OH are not the same. OH will be different and double OH will be similar to having a H. So this is what we call our acid and base. So when we talk about acids, our acids should have H, our bases should have OH. So let's go to the next part then. So our next part is a small revision of our earlier classes, class 9 and our chapter 1. What we learned was, when writing HCl or hydrochloric acid, what do? Is we write hydrogen and we write chlorine. We put the valency of hydrogen, we put the valency of chlorine, and we cross them. And when crossing, we get H1Cl1. But one we do not write, so we write HCl. I hope you remember it. Let's try for some more. Hydrogen and sulfate, let us say HNSO4. H valency is 1, SO4 valency is 2. So if you cross it, what will you get? H2SO4, and the name of this is sulfuric acid or hydrogen sulfate. We don't call it hydrogen sulfate, we call it sulfuric acid. Same goes for HNO3. NO3 valence is 1, H valence is 1, so if you cross it, we get HNO3. For the bases also similar. If we take Na and OH, sodium and hydroxide, valency 1, 1. So if you cross it, what do we get? NaOH. Similarly, if you go for calcium hydroxide, Ca valence is 2, OH valence is 1. So what do you get if you cross them? We get CaOH2. Because OH is a group, or this was what we call as polyatomic ions. So when we have polyatomic ions and we have to put a number behind a polyatomic ion, we have to put the polyatomic ion in the bracket. So I hope you remember it. So this is how we're getting it. So this is just a small reminder. Now let us try to see what exactly are acids. I already told you acids will have H in them. So let us look at two compounds. Let us say HCl, H2SO4, three compounds. Let us say C6H12O6. You remember it? Hydrochloric acid or hydrogen chloride, hydrogen sulfate, or it's actually called as sulfuric acid. And this one, you know it already. What was it? Our glucose. So what is the common in all these three compounds? The common is all three of them have got hydrogen, hydrogen, and hydrogen. So let us see what will happen if I dissolve HCl in water, H2SO4 in water, and C6H12 in water. If I put HCl in water, it will dissolve to give us H plus Cl minus. H2SO4 will give us H plus, and SO4 2 minus. Not here. Why am I putting 2 H plus here? Because there are two hydrogens here. And why SO4 is coming minus 2, not only 2, sorry, not only minus, but why 2 minus? Because SO4 valency is 2, so it will produce 2 minus. Hydrogen valency is 1, so it will produce 1 plus. Chlorine valency is minus, a single 1, so it will produce a single minus. So I hope you got it. So what we see is HCl can release H plus ions. H2SO4 can release H plus ions. Yes, H plus ions. When do they produce ions? When dissolved in water. However, our glucose cannot break down. When you dissolve it in water, it will remain C6H12O6 and it will not break down. As a result, no H plus will be produced. So we say glucose is unable to produce H plus. And to consider something as acid or to qualify as acid, that ability they should have is they should be able to release H plus ions in water. Same goes for CH3COOH. Why was it similar to producing our, why was it not OH, but why was it OOH? What was the difference between OH and double OH? It was when you dissolve acetic acid in water, it forms CO minus and a H plus. So whatever is producing H plus, we'll consider it what? Acid. So here, this is what we call as our acid, and it's a common thing. So this one I can call it positive ion or positive radical also. So when I say positive radical, and this I can call as negative radical. So I hope you will remember it. So then let's go to what the common thing or what is the base and what can they do. So let us take the base, our NaOH, CaOH, 2, and let's take one more, something called as C2H5OH. This is our called as ethanol or our alcohol. Okay, so here similarly, when I put NaOH in water, it will become Na plus and OH minus. Our calcium will be calcium hydroxide, CaOH will become Ca2 plus, why 2 plus? Because valency is 2, and OH minus, OH minus. See, it's giving 2 OH minus because there is 2 here, 2 OH. However, alcohol has got OH, but when I dissolve this in water, it cannot break down to give OH minus. As a result, alcohol or ethanol will not be considered as a base. Only those which can release OH minus in water are what we consider as base. So I hope you got it, and I hope you understood this also, that what was it? H3COOH and NaOH. I told you the difference. Having OH will release OH minus in water, so it's a base. Having OOH will release H plus in water, so it is an acid. So I hope this part is clear to all of you. So then let's go to the next part. So for the next part, let's try to understand how can we distinguish between our acid and base. So acid and base, both of them are corrosive. Corrosive means both of them will eat away certain things. For example, if it falls in your skin, in your hand, it will eat away your skin. As a result, it will burn your hand. Or maybe if you put an iron nail inside it, it will react with the iron, it will eat away the iron. So corrosion or corrosive. So here acid can be different type, base can be different type. Some acids are strong. That means if I take a strong acid, put your finger inside of it, your skeleton will come out. Base also same, it can be strong or weak. So strong acid or strong base, we'll call it concentrated. Concentrated acid. Maybe we'll write concentrated CONC dot HCl. Maybe I will write CONC dot H2SO4 and so on. So when you see this, you'll understand, okay, this is concentrated, meaning very, very, very strong. If one drop falls in your hand, there will be a big hole in your hand. Next, our weak ones will call as dilute. Maybe dilute, HCl and so on. Means this one, if dilute acid, depending how much dilute it is, because we already learned in class 9, concentrated and dilute are comparative. The stronger one is called concentrated, the weaker one is called dilute. So whatever, generally when it's a dilute, it will not be that effective. For example, if it falls in your hand, you might feel warm, but suppose it's a strong dilute, you may get harmed, you may get burned. So we should always be careful with acids and base. So let us look at two weak acids. Okay, I'm not using the word dilute, I'm telling weak because they are generally very weak, or they will not harm you that much. So let us look at two weak acids. Our citric acid, which is found in our lemon. Okay, sorry, one weak acid found in lemon, and one generally very weak basic. I'm not calling base, I'm calling basic. Our soap. Basic meaning it is not exactly a base. Why is it not a base? Because it does not have OH. Okay, however, the reactions, whatever a base show a reaction, our basic shows a similar reaction, so we call it basic. So we have got soap here. Our lemon, I can call it acidic because it contains acid. Okay, what acid? Citric acid, you can see in the book. So let's just see how they taste. What's the taste of lemon? Sour. What's the taste of a soap? Bitter. That means a general idea we can see is acid will be sour in taste and base will be bitter in taste. Generally we can say this. Okay, so this is how we can test for the difference. Test, not taste. Okay, test for the difference between acid and base. So here I already told you, or the topic was how can we test the difference between our acid and base, or how can you tell the difference. So first thing is by tasting their taste. However, I already told you acid and base are dangerous, they are corrosive. That means if you take a strong acid, maybe concentrated HCl, put your tongue on top of it, your whole tongue will get burned. So it's not a very good idea to taste for acid or base. So how do we differentiate them, or how will you test it? We will test it by using some chemicals called as indicators. Okay, and when I say indicators, some of them can be chemical. In the book you can see, or in the notes it's already given, something called as phenolphthalein and methyl orange, and some can be natural. Our natural will come. The most common is litmus, and we have got our red cabbage, onion, and so on. Here, when I say indicators, what is their function? Their function is to tell us whether something is our acidic or acid, or whether it is a base or basic in nature. How does it do it? It can do it by either changing the color or maybe by changing the smell. So here our onion, it changes the smell when put in acidic medium. Smell for onion. Hence we call it olfactory indicator. Olfactory indicator. Olfactory means related to our nose. So already notes is given. What are olfactory indicators, or what are indicators? Indicators are those which can tell whether something is an acid or a base. What are olfactory indicators? Those which can tell something is acid or base based on the change of their smell, or you can order also. Odor means you know already bad smell. So this is how our onion will work. However, litmus paper, red cabbage, and our chemical indicators phenolphthalein and methyl orange, they will change the colors when we put in acidic or basic medium. So here our focus is on our litmus paper. So from where we get litmus? We can get litmus from lichens. What was lichens? A symbiotic relationship between some species of algae and fungi. I hope you remember it. In class 9 we got it. Symbiotic meaning what? What was it? It was, suppose there are two people, A and B. A goes to the market, brings all the things or all the necessary things to B. B will cook it and give it back to A. In this case, A will go to the market, B will cook. Let us say A doesn't know how to cook and B doesn't know how to go to market. So here what is happening? A is helping B, B is helping A. Both of them are benefiting from each other. That is what we call a symbiotic relationship. Here, algae can do photosynthesis, so it can produce food. Fungi cannot do photosynthesis, so it cannot produce food. Then what does a fungi do? Fungi will give all the necessary nutrients to the algae. Algae will give some amount of food back to the fungus. As a result, both of them are benefiting. So symbiotic relationship. So whatever that was in our class 9, just small reminder. Here we are talking about litmus, and if you take that extract from lichens or the color from the lichen and put it in a paper, we call it litmus paper. Now, why is litmus paper so important? Because it is a universal indicator. Universal means it can detect both acid and base. Some of them can detect only acids, some of them can detect only base, but universal indicators can detect both acid as well as base. So what happens when I put litmus paper into an acidic medium, or I put it in acid? It will turn, obviously I'm writing with red, it will turn red. Next, when I take the litmus paper and put it in a basic medium, it will turn our blue. Litmus paper turns blue in basic medium. Litmus paper turns red in acidic medium. How will you remember it? Remember B and B. B for base, B for blue. For whom? For our litmus paper. So I hope this way it will be easy to remember. So this is how we identify between, or that we differentiate between acid and base, and this is how we can call, or what is it, this is what we call as indicators. So our next part will be our reactions of some acid and base.